Hi students of physics. Today we are going to determine the mass of the earth. Just consider an object lying on the surface of the earth. Remember, the mass of this object is quite negligible as compared to the mass of the whole earth. And now we have to apply the Newton's law of universal gravitation to this situation, where we have a mass, very little mass, very minute mass of the object lying on the surface of the earth, and the huge mass of the earth, and we have also the distance between these two bodies, the minute object and the whole mass of the earth. When we apply the formula of Newton's law of universal gravitation, force of attraction between these two bodies, mass of the object and the earth, is directly proportional to the product of their masses. Product means if you multiply the mass of that object and the mass of the earth, and that is the product of there's a product of these two masses. So according to the first postulate of this Newton's law of universal gravitation, the force is directly proportional to the product of these two masses, and the same force is inversely proportional to the square of distance between these two masses, between these two objects. Number one is the object lying on the surface of the earth, and second is earth itself. You can see that the center of that minute object, or the center of gravity of that minute object lying on the surface of the earth, is so small, it's quite negligible. So we can consider the distance between these two masses as the radius of the earth. So radius of the earth means now F is inversely proportional to the square of radius of the earth. If we merge these two equations, we have F is proportional to the product of these masses, and divided by the radius of the square of the radius of the earth. Now we have to apply some constant to this equation to make it the equivalent to each other. Like if we apply capital G, that is gravitational constant, so we have the formula F equals to capital G, that is gravitational constant, multiplied by mass of the object lying on the surface of the earth, multiplied by mass of the earth, divided by square of the radius of the earth. So that is the formula we have initially obtained by operating these proportionality, operating these relations, and by applying the Newton's law of universal gravitation. At the same time, we know that weight of anybody is again a force. Weight of anybody is again a force, and that force is the force with which the earth attracts anybody towards its center. Yes, so again we have a force in the form of the weight, so we can say that F is equal to W, weight is equal to according to the formula mass multiplied by small g. Small g is the gravitational acceleration. You must have studied all these basic things like difference between mass and the weight, and the gravitational acceleration is small g, and the capital G, gravitational constant, of course. Now we have two main equations. F is equal to capital G, mass of the object multiplied by mass of the earth, divided by a square of the radius of the earth. Now if we compare these two equations, we have mass of that object multiplied by G is equal to capital G, mass of that object multiplied by mass of the earth, divided by square of radius of the earth. If we simplify these equations for mass of the earth, we get the equation that radius of the mass of the earth equals mass of the earth equals radius of the earth square multiply by small g, that is gravitational acceleration, divided by capital G, gravitational constant. Now we have to put the values of all these capital G, small g, and radius of the earth. Values are already given on the screen. You can see, if you put all these numeric values to this equation, finally we get the mass of the earth, that is 6 multiplied by 10's power 24 kg in kilogram. Yes, this is the scientific notation of expressing the mass of the earth. If we convert this scientific equation into the standard form, we can see that 6 after 6 we have to write down the 0 24 times. Yes, now this is the standard form of the mass of the earth in the same unit kg. Goodbye.